Okay, this is one of the reactions. We're not responsible for the mechanism at all.
We just need to know what the product is.
Yes.
Okay.
So remember, this is a substitution SN2 chemistry. What is the final product? Oh.
How do you recognize that so quickly as SN2?
Because I know that under these conditions here, we do SN2 chemistry. If you go to your book,
Is it because it's is it considered a weak base or a strong base?
I think that one is a weak base, but really, the idea in my mind that is a SN2 chemistry comes from here. These two guys are not responsible for know the mechanism, but we're responsible to know what is required. So an alcohol and SCO-Cl2 do E2 chemistry.
E2 or SN2?
Oh, SN2.
Okay.
And then PBr3 do the same thing, but instead of adding the Cl, it added the Br.
Okay.
So you're not responsible for the mechanism, but you're responsible to know when you look at it, you need to recognize this is a SN2 chemistry.
Just based off of the base.
Okay. And when we look at this, the final products of that reaction is going to be the chloral propane,
Okay.
the 1-chloropropane, and then we're going to end up with sulfur dioxide and HCl, right?
Yes.
Okay.
But we're not really worried about this.
Yeah,
This
we
is
only worry
organic.
about we just worry about the organic
Organic.
products.
Yeah.
Okay.
But this is all, if you have your beaker, you have your primary alcohol, you added that, you got it all this in your beaker.
Okay. Now, does this only work with primary alcohols?
Mm-mm.
Or is just the only, we know that it's SN2 an SN2 mechanism because it's a primary alcohol?
Because it is a primary alcohol, we know that this guy here will do.
Especially since there's no possibility for methyl shifts whatsoever.
Yeah. But this is one of the reactions you need to remember, but you don't need to know the mechanism. And this is the two here. If you go in the back of your book, page 176, you have the two in there. That's two guys. So you're responsible for when you throw in a test, something like that, you need to look and say, okay, I know where's the final product. I don't think, we use actually this reaction at the PBr3 a lot in 352 for synthesizing.
Okay.
Because I think the PBr3, they gave you a 80% yield, something like that. So for synthesis, it's really good.
Okay. So this same thing can happen with PBr3?
Yeah, you
Okay.
could do that, or you could have this. And now here instead of Cl, you have this.
Okay. Awesome.